The Kuiper Belt is a doughnut-shaped region of the solar system that astronomers find fascinating. It stretches beyond the orbit of Neptune and is home to numerous icy bodies. This area of the solar system is fascinating because though it exists, it does not match the predictions made by the nebular model of planetary formation. The Kuiper Belt begins at roughly 30 astronomical units, or AU, from the Sun, which is just beyond Neptune, and extends out to about 55 AU. In general, objects in this region are called Kuiper Belt objects, which are icy bodies ranging in size from small chunks to dwarf planets. Dwarf planets are the most noticeable objects found in the Kuiper Belt because they are the biggest. They include Pluto, Haumea, and Makemake, and they are clearly the largest bodies found in this area. Many short period comets, such as Halley's Comet, are thought to originate in the Kuiper Belt, but this is just pure speculation based on the fact that they could not have survived in their current orbits for billions of years. Observations of Pluto and other KBOs reveal surprising diversity. Pluto has evidence of a young active surface that includes glaciers, mountains, and possibly even subsurface oceans. Haumea spins so rapidly that it is elongated. Furthermore, it is unique among dwarf planets in that it has a ring system. It lacks evidence of being the cold, sterile region that it originally was supposed to be. The Kuiper Belt is far less massive than early solar system models predict. This has led to questions about what happened to the missing mass. However, this presupposes that the models are right and that the mass was there in the first place. The simplest explanation is that the models are wrong and the mass was never there in the first place. The peculiar orbits of many of the bodies discovered in the Kuiper Belt region have been used to suggest the presence of a ninth planet. However, such a planet is yet to be found, and the hypothesis presupposes that the orbits were roughly circular to begin with. KBOs have a significant variety in chemical makeup for which a nebula model planet formation has no clear explanation. One clear explanation would be that the model is wrong. All of these issues are solved when the problem is looked at from a creationist perspective, not just because God could have done it any way he wanted it, but because creationist models actually provide a solution. At the very least, when you eliminate the billions of years, many of the problems naturally go away. For example, you do not need a constant supply of comets in a young solar system. Models of the Genesis flood and other factors would all suggest that the entire solar system was affected at that time. We have diverse bodies in what amounts to be an outer asteroid belt because some of them are flung there by the influence of the planets after being formed during that time from different sources. New Horizons is the NASA spacecraft that performed a historic flyby of Pluto in 2015. It later visited the KBO M69 in 2019, revealing details about its shape and composition. Future missions include advanced telescopes and space probes that are being designed to explore this enigmatic region. In conclusion, being much more than a bunch of rocks, the Kuiper Belt is a treasure trove of information about our solar system. Furthermore, studying this region will help us to learn more about the processes going on within the solar system. As our spacecraft technology becomes more advanced, this distant region of our solar system will reveal more of its secrets. If experience is any indication, it will produce more problems for the naturalistic models of the origin of the solar system, rather than solve them. If you like this content, please support this channel by making a donation or buying a product through the links mentioned in the description.